of 90% and takes home 14 points. So that was the overlapping area metric. Now, what makes this a good metric and what makes this a bad metric? Think about that for a second. Alright, first let's talk about the good parts. There are 3 important things I would like you to pay attention to here. First, if we have a shape and we make it more rounded, then the overlapping area will be greater, so our measurement will be greater. This is exactly what we want. If we make a shape rounder, it will have a higher circularness. Second, let's try to measure the circularness of a perfect circle. Well, we simply draw a circle of equal area, and 100% of the area is overlapping, so the circle's circularness is 100%. This is not the case for any other shape. Only circles are 100% circular, which again makes sense. Third, a big square and a small square both have the same circularness because the circle that's used to measure them scales with the square, if that makes sense, because of the equal area thing. Alright, we'll come back to these 3 things soon. Now remember when I said that there is no objectively correct way to measure circularness? While that is true, we still want to have some rules throughout this video, otherwise we'll end up with completely ridiculous measurements. So here are our 3 rules. Number 1. The more circular a shape gets, the higher its circularness should be. Pretty self-explanatory. Rule number 2. A perfect circle should have circularness 100%, and it should be the only shape with circularness 100%. And rule number 3. Circularness should not depend on size. If you have 2 squares and one is bigger than the other, they should still have the same circularness. Now as we just saw, the overlapping area metric satisfies all 3 of these rules, so we can consider it a valid metric. However, there are still some weird side effects. For example, consider this string. It's very thin, so it doesn't have much area, meaning the circle we use to measure it will be pretty small. Therefore, the amount of overlapping area will also be small, so this ring only has like 10% circularness according to this metric, while squares have 91%. Me personally, I think this is ridiculous. The ring feels much more similar to a circle than the square does, but you know, maybe that's just me. So that's weird side effect number 1. Shapes that are very thin tend to have extremely low measurements. Now there's another problem with the overlapping area metric, which is that it's quite difficult to calculate accurately. If I give you a shape like this, it's very hard to measure because you don't know exactly where the circle should be positioned in order to achieve maximum overlap. You would need to test a bunch of different positions, record the percentage for each one, repeat this process several more times, then pick the highest percentage to use as the measurement. And even then, there's a chance that your measurement is wrong. Maybe there was a slightly better location to place the circle in and you missed it. Now you may have noticed something interesting about circles while watching this video. If a shape and a circle have the same area, and you compare the perimeters of both shapes, it turns out the circle's perimeter is always smaller than